Hello class, this is Mrs. De Oliveira. You are viewing Lesson 3, solving one-step equations using addition or subtraction. And the objective for this lesson is how can we solve addition and subtraction equations? First of all, we are going to use models to solve this particular one-step equation, x plus 3 is equal to 7. Now I know that many of you can reason that x should be 4 because you know that 4 plus 3 is 7. However, it's very important for us to learn the process of solving equations because they'll become much more difficult than this later on. So in order for us to use models, we are going to go to the Huda Math website where I already have set up my balance, my scale, and it's nice and balanced, and I have my x tile plus 3 ones is equal to or balances with my 7 ones. And I also have my equation off to the side. So the whole idea of solving an equation is to get the variable, the letter, the x by itself. Well, one way we can do this is we need to get rid of these 3 ones tiles. So if I do that, if I just throw out the 3 ones tiles, which is the same thing as subtracting 3 in an equation, my scale is not balanced anymore. So this is no longer an equation. Some of you may say, well, what if I took the 3 tiles that are here and I move them away from the x, but I put them onto the other side? Is it balanced? No, it's not balanced anymore. So that doesn't work. Let me get rid of those 3 that I added on. So here I have x, and I have 1, 2, 3, 4, 5, 6, and 7. Not balanced. So what I can do is, if I'm taking away 3 on one side of the balance, maybe if I take 3 away from the other side, and lo and behold, it's balanced. And if you notice what I'm doing, I now have the x by itself, and we see that it's equal to 1, 2, 3, 4. And again, you could have figured that out just by thinking, all right, I know that 4 plus 3 is equal to 7. But again, it's important to realize the process. So if we look at our balance, whatever we do on one side of our balance, of our scale, we need to do the exact same thing on the other side of the scale so that it stays equal, so it stays balanced. And that leads us into our process for solving equations. So it deals firstly with our definition of inverse operations. So those are operations that undo each other. They cancel each other out. So one example of that is if you subtract 5, that's the inverse of adding 5. Just like we saw on our scale, we started off with adding 3, then we took away 3. So the subtraction property of equality states that if you subtract the same number from both sides of an equation, the two sides will remain the same. So here we have a concrete example. We know for a fact that 3 plus 4 is equal to 7. So if we subtract 4 from both sides, does this stay the same? Does it stay as an equation? Well, we end up with 3 plus 0 is equal to 3. And how does that happen? Well, the original 3 carries down. A positive 4 minus 4 cancels out because they're inverse, and that equals 0. And you bring down your equal sign, and then you can actually do 7 minus 4, which is equal to 3. So as you can see, if I do subtraction on one side and subtraction on the other side of an equation, the answer remains the same. So now let's look at an example that involves variables. So here we start off with an equation that says n plus 35 is equal to 80. So we start off with an addition problem. So we need to do the inverse of addition, which is subtraction. And again, in order to keep it balanced, we do on one side, we need to do to the other side. So our variable comes down, our n. The plus 35 and minus 35 cancel out, become 0. We bring down our equal sign, and now we can actually subtract 80 minus 35, which gives us 45 as our answer. So our answer, or our solution, is n is equal to 45. Another example, 16 plus x is equal to 42. Looks a little different because the x doesn't come first. However, the steps are still the same. My 16 is a positive number. It's added with the x. So in order for me to move it away from the x, I need to subtract 16. So the positive 16 and the negative 16 cancel out. Our x comes down, our equals comes down, and when we do 42 minus 16, we get 26 as our solution. So for this particular equation, x is equal to 26. One more addition example. So again, our variable is in first, but the steps are still the same. We have a positive 125, so plus 125. The inverse of that is to subtract 125. The 125 minus 125 cancel out. Down comes our x, down comes our equal sign, and when we do our subtraction, we get our answer of 295. Now, on the other end of it, the addition property of equality, if you add the same number from both sides of an equation, the two sides will again remain equal. And again, we're going to use something that we know is true. That's 7 minus 4 is equal to 3. So since I'm subtracting 4 to start with, 7 minus 4, I would need to add 4 on each side. And what happens there? Well, the 7 comes down, a minus 4 plus 4 cancels out to 0, down comes our equal sign, and we know that 3 plus 4 is equal to 7. So we added 4 on each side to a problem that started off as subtraction, and it's now balanced and equal. So let's take a look at a few more examples. So here I start off with an equation that says w minus 36 is equal to 56. Since it starts off as subtraction, I need to use the inverse. I need to use addition. And again, the same process occurs. The w comes down, minus 36 plus 36 cancels out, down comes our equal sign, and now we can actually add 56 and 36, which gives us 92 as our final answer. Example 5. Looks a little flip-flopped, but nothing changes. Where's our x? This time the x is on the right-hand side of the equation. What's happening with the x? We're subtracting 12 from it. So in order to solve this equation, we need to add 12. Then, going left to right, I can do 23 plus 12 is equal to 35. Bring down my equal sign, bring down my x, and my minus 12 and plus 12 cancels out. X is 35. And our final example, c minus 123 is equal to 445. Again, it starts off as a subtraction, so we need to use addition, the inverse operation. Down comes the c, the 123's cancel out, down comes our equal sign, And when we add our numbers, we get 568. So C equals 568. So those are your examples for today's lesson. Please go on to the course site and complete your practice problems, your assignment for today. Thank you.